Here we're going to talk about properties of liquids. Some of these properties that we'll talk about: surface tension, viscosity, and vapor pressure. So surface tension, we're probably a little bit familiar with this already. This is actually a quantitative measurement of the elastic force in the surface of a liquid. So one that you're probably most familiar with is water. And you know, if you fill a cup up to its the rim, and you can actually have it go a little bit farther and it bubbles up over the top. That's those individual water molecules holding on to each other, and that's an intermolecular force being responsible for that, and that results in surface tension. So it's the amount of energy required to stretch or increase the surface of a liquid by a unit of area is the formal definition there. So like I said, a liquid with strong intermolecular forces has a high surface tension. So that's why we know water, which has hydrogen bonding interactions, which is a high strength intermolecular force. So water has quite a bit of surface tension, for example. And this is responsible for things like also the meniscus when we've been measuring water. So here, that is dealing with the intermolecular forces between water and itself, as well as water and the glass. You can have other liquids, like there's liquid mercury, that actually has the opposite meniscus that is bubbling up versus down. And that just depends on the intermolecular forces amongst those individual atoms or molecules, as well as the forces between itself and the container, like the glass container. Okay, so that's surface tension. We also have something that seems somewhat similar. It's called capillary action. This is where water is pulled up into a narrow glass cylinder. So water can act, you maybe have seen this before. There's two types of forces bringing about capillary action. There's cohesion and adhesion. Cohesion is the attraction between like molecules. Adhesion is the attraction between unlike molecules. So this is very similar to the meniscus idea on the prior slide, where you have some sort of cohesion amongst the water molecules and adhesion from glass to the water molecules, helping those water molecules climb up that narrow container. And this is how, for example, trees, without using any energy, can pull water from their root system up into their leaves, for example. It's using capillary action that can draw that water up against gravity without exerting any energy to do that. It's utilizing this physical property of water. Okay, another property is viscosity. Viscosity is the measure of a fluid's resistance to flow. Don't really worry about the units, but the units are newtons times seconds per meter squared. The higher the viscosity, the more slowly a liquid flows. Maybe a classic example is a very viscous solution would be like maple syrup, or something that is not very viscous. Certainly water is not very viscous, but even less so would be things like alcohol, very not viscous. And liquids that have strong intermolecular forces have higher viscosities than those that have weaker intermolecular forces. So very similar features to other properties. All right, another property is vapor pressure. Again, this is going to depend on the magnitude of those intermolecular forces. And as a classic, vapor pressure will increase with temperature. And we already knew this in dealing with the partial pressures of water. When we were collecting gas over water, we knew the partial pressure of water, meaning the vapor pressure of water, was you could find in a table based on the temperature that you were dealing with. So this certainly the magnitude of those intermolecular forces will affect how easy it is to vaporize that particular compound or atom. And if something is very easily vaporized, we call that a volatile substance, volatile liquid. So they have a high vapor pressure at room temperature. And this, since it goes along with, so this will go along with boiling point as well. So if something has a low boiling point, it is going to be volatile.